This is session 1 of the topic Light, Reflection and Refraction, the chapter that you find in the CBSE Class 10th Physics as well as ICSE Class 10th Physics. In this session, we will know about the meaning of light, what are its uses, the nature of light, then reflection and its laws, and we will know about types of images and types of mirror. And the next part, we will know more about the topic light. In this session, first we'll begin with light. What is light? Light is a form of energy. Why do we say that light is a form of energy? It is because light can do work. What kind of work light can do? Light can do good amount of work because when light falls on a photovoltaic cell, means solar cell, it produces electrical energy. So anything which has got energy has the capacity to do work. So light is a form of energy because it can do work. Light can burn a piece of paper if it is focused on the paper. So light is a form of energy. Light is an electromagnetic wave. Why light is called an electromagnetic wave? Why? Because as light propagates, its propagation is due to the variation in the magnitude of its electric field and its magnetic field. Light travels all the way from sun to earth without the help of a material medium. Just by changing its own magnitude of electrical and magnetic field, light takes just 8 minutes to reach the surface of earth. So light is a self-propagating wave. It doesn't need a mechanical medium for its propagation. So it's a non-mechanical wave. So it is an electromagnetic wave. So light is a form of energy. It is an electromagnetic wave. Light's mode of propagation is a transverse mode. So light propagates in transverse mode. It has visible part and the invisible part. Visible part is called the VIBGYOR, where the VIBGYOR or the visible part of light has 7 components. The VIBGYOR, violet up to red and green in the middle. So violet is 400 nanometers in wavelength and red light has a wavelength of 700 nanometers approximately, where green has a wavelength of 530 nanometers. So that's a visible part. So any object that emits light from 400 nanometers to 700 nanometers can be easily sensed by human eye. But below 400 nanometers and beyond 700 nanometers is invisible light for human eye. Human eye can't see. So below violet there is ultraviolet. Ultraviolet are high frequency, low wavelength radiations. And beyond red there is infrared, which is high wavelength and less frequency waves. So the part of the component of light which has got high frequency has more energy. By Einstein's relation, E is equal to h nu. More the frequency, more energy. Infrared radiations are responsible for heating up. That is one of the uses of light. Now that was about light, its uses and what it is all about. So what are the uses of light? We already saw. And have you ever heard that light is used in the long distance communication? How light is used in long distance communication? By focusing light, okay, fine, but also through optic fibers. What are optic fibers? Optic fibers are nano dia fibers through which, if once the electromagnetic waves, means light waves, are incident, those light waves undergo multiple internal reflection and they travel to long distances without any loss of energy. And where do we use optical fibers? Optical fibers are used in telecommunication purpose. So like the landline phones, when we talk at this end, the other end may be a long distance, the sound is heard at the same frequency. Optic fibers is also used in the field of medicine. So those are the places where we use light. Now, what is the nature of light? Like we know that there is light, but we should know its nature. So light has basically 3 nature. One is the ray nature, another is wave nature, and the third is particle nature. How do we know that light has a ray nature? We know that light has a ray nature because we see certain phenomena around us as a reflection of light and refraction of light. Reflection and refraction are common phenomena that we see in our day-to-day life. So we just assume that light has a ray nature. So What is reflection? Reflection means when a ray of light falls on a polished surface, it bounces back into the same medium. So we use the word ray of light. And reflection, you see in the second diagram. In the second diagram, we see that a ray of light incident on a mirror or a polished surface, it bounces back, or a ray of light on a transparent material medium, it deviates from its path, but the ray of light exists. So if a ray of light is incident on a polished surface, it bounces back into the same medium. So it is about a ray of light. So we see this kind of nature in every day, like it's a natural phenomena. So we assume that light must be having a ray nature. What is refraction of light? You see in the first diagram, a pencil that is kept in water. In the immersed part, the pencil appears to have bent. So upper part, the pencil is actually a straight one, but it appears, the immersed part of the pencil appears to be bent. So a ray of light, when it travels from denser medium to rarer medium, the ray of light bends at the medium of separation. That is called refraction of light. Since we see certain phenomena like reflection and refraction, we say that light has a ray nature. What is wave nature? We see some phenomena like diffraction of light. Diffraction of light is the bending. Diffraction of light is the phenomena of bending of a ray of light at the edges of an obstacle. You can assume that, like if we have a solid opaque object and rays of light or a beam of light is incident on this opaque object. Since it is opaque, much of the beams will not pass by, but at the edges of this, the light rays just bend, they will bend. Okay, so bending of rays of light at the edges of obstacle. So it may bend inward, it may bend outward, but they bend at the edges of the obstacle. Bending of a ray of light at the edges of an obstacle is called a diffraction, and that is due to wave nature of light. The third one, particle nature of light. How do we know that light has particle nature? Light travels in form of particles, not exactly individual particles. It travels in form of packets of particle, and each packet of light is called a photon. Each packet of light is called a photon. So when light, which travels in form of particles, not exactly individual particles, a packet of particle or packet of light, which are called photons, when they fall on a solar cell or a photovoltaic cell, the photovoltaic cell, which generally stays as an insulator, becomes a conductor. That means electrons which are not mobile on a photovoltaic cell, they absorb the energy of these photons. So light travels in form of particles. Every particle, not individual particle, a packet of particles. So that pack of particle has a certain frequency. So that photon also has certain frequency. Then Einstein gave a relation E is equal to h nu. So when this packet of light falls on a photovoltaic cell, solar cell, the electrons in the photovoltaic cell absorb this energy, they break the bonds, now they are free and they are mobile, and when electrons are mobile in a substance, there is electric current. So since we notice this kind of phenomena that when light falls on semiconductors like silicon or germanium, with which we prepare the solar cells or photovoltaic cells, when light falls on them, electric energy is produced. Since that is observed, that's a natural phenomena, so it is guessed that light has particle nature also. So light has a ray nature, wave nature and particle nature. So these three are the diagrams. The first one is about bending of a ray of light, so refraction of light at the medium of separation. Second one is a bouncing back of a ray of light when it is incident on a polished surface, that's about reflection. And the third one is a wave nature of light, that is a diffraction. Diffraction means when light, you see there is a small slit here. When light passes through the slits, from behind the light is focused, at the edges of the obstacle light is just bending, and that is called a diffraction. So these phenomena we see about light, so we say that light has three nature: ray nature, wave nature and particle nature. Our chapter in class 10th physics in CBSE and ICSE syllabus is about reflection of light. So what is the meaning of reflection of light? Reflection of light is defined as It is the bouncing back of a ray of light from a polished surface. So when a ray of light, you see the diagram, the first diagram where rays of light from an illuminated source. So here it is the sun. When it falls on a notebook and reflects to our eyes, then we are able to see what is there in the book. So bouncing back of a ray of light from a polished surface is called reflection. But there are two types of reflection. One is called a diffused reflection, and another is a regular reflection. In the notebook, you see diffused reflection. Diffused reflection. On cinema hall screens, we see diffused reflection because the notebook or the book, the cinema hall screen, those cloth, the cinema hall screen's cloth, they are not polished surfaces. So on that, when a beam of light is incident, that is reflected in every direction. So everyone in that hall, cinema hall, is able to see what is there on the screen due to diffused reflection. But basically what's the definition of reflection is? It is the bouncing back of a ray of light when it is incident on a surface. But the surface must have the capacity to reflect it. Bouncing back of a ray of light when it is incident on a polished surface is called reflection. Then there are two laws of reflection. So there is first law. First law of reflection states that the angle of incidence is equal to angle of reflection. So here you see in the second diagram, a ray of light is incident on a polished surface. So this horizontal line is a polished surface, which is a mirror. So when a ray of light is incident, it is reflected. Now at the point of incidence, if we happen to draw normal, then the angle between incident ray and normal, I'm writing N for normal, and I for incident ray, and R for reflected ray. I'll be using the same I and R for angle of incidence and angle of reflection also. Angle of incidence, angle between incident ray and normal is called angle of incidence. Angle between reflected ray and normal is called angle of reflection. The first law of reflection is angle of incidence is equal to angle of reflection. Second law of reflection is the incident ray, the reflected ray, and the normal at the point of incidence lie in the same plane. Lie in the same plane. Lie in the same plane's meaning is you will find incident ray, normal, reflected ray on the same side, on the same surface. It's not that it will cross from surface to surface. No x, y, z. It's only 2D surface. So they lie in the same plane, an xy plane. So this is law of reflection. Now, reflection is a bouncing back of a ray of light when it is incident on a polished surface. So images are formed due to reflection. How many types of images are there? There are two types of images. One is called a real image, another is called a virtual image. So what is a real image and what is a virtual image? Real image is the image formed by actual intersection of real image is the image formed by actual intersection of reflected or refracted light rays. Image that is formed by actual intersection of reflected or refracted light rays. And what is virtual image? Virtual image is an image that is formed by without the actual intersection of reflected or refracted light rays. So you see here we see in the picture 1 and the picture 2. Here the image of when we stand in front of the mirror, our image is formed inside the mirror. So when we are talking about types of images, so either our image that is formed inside the mirror is a real image or it is a virtual image. So you think about it is a real or virtual. So it's definitely a virtual image because the thing that we see inside the mirror is not the reality. Reality is us. So that is the image of the reality. So that is virtual. Though virtual definition is different. Virtual image is image formed without the actual intersection of reflected light rays. So all virtual images are erect. That means they are the way the object is. But real images are always upside down, inverted. So in figure 1 and 2 you see the real image. So plane mirrors always form Virtual images. Plane mirrors always form virtual images. So all these three pictures are of virtual image. Then how does a real image look like? So I make use of this space to tell you how the virtual image, real images form. You see, in case of a concave mirror, when a ray of light is incident on the mirror, it is reflected, and the reflected light rays intersect at a point. You see, where is the point of intersection? It is in front of the mirror. It is not inside the mirror. So here this image is formed by actual intersection of reflected light rays. So this is a real image. Every real image can be caught on screen. Like here, if you place a screen, you can clearly see the image of the distant object. And every real image is inverted. You won't see the real image inside the mirror. Real images are never formed inside the mirror. They are only caught on the screen. Virtual images are not caught on the screen. Virtual images are caught inside the mirror. Now let us define and differentiate the real image and virtual image. So the first point is always the definition. So about the real image. So what are real image? Real image are images that are formed by actual intersection of reflected or refracted light rays. The definition for virtual images are images that are formed by without the actual intersection of reflected or refracted light rays. So real images are caught on screen. Virtual images are not caught on screen. Plane mirrors always form virtual image. Second point is all real images are inverted. All real images. This is a common statement. All virtual images are erect. Erect means they form up above the principal axis. That means like how we look like we are above principal axis. So our images are also above principal axis. We don't look upside down. Third point, real images can be caught on screen. We can catch the image of any object, distant or near, on the screen if it is a real image. Virtual images cannot be caught on screen. Virtual images are only seen inside the mirror, and that too in case of plane mirror. In other cases also virtual images cases are there, but plane mirror always forms virtual image. The last point, images formed by concave mirror, except the last case when object is placed very close to the mirror, are real images. Images formed by plane mirrors are always virtual. You saw the picture of the two people who were looking inside the mirror, and their image is formed inside the mirror. Every day when we stand in front of the mirror, we see our virtual image. That is why the image is erect and as it is, the way we are our images. So they are the virtual images. Virtual images are erect, that's all. It's not about the size. Okay, it's about erect. Real images are always inverted, and they are not formed inside the mirror. They are formed in front of the mirror, and that can be caught on screen. Virtual images cannot be caught on screen. So we are talking about images. So who are forming images? Mirrors are forming images. So how many types of mirrors are there? There are two types of mirrors. One is a plane mirror, another is a spherical mirror. So first we'll begin with the characteristic feature of a plane mirror. This is a 3-mark question often seen in most of the board exam question papers. So what are the characteristic features of plane mirrors? Plane mirrors have excellent characteristic features. Every day that you see in the plane mirror, that's a characteristic feature. The first point, object distance is always equal to the image distance. That means at what distance from the mirror we are standing, our image also stands at the same distance from the surface of the mirror. Second point, height of object is always the same as height of image. Size of object, size of image are same. Third one, lateral inversion is seen in case of plane mirror. You must have noticed if there is a plane mirror, this is the mirror. Okay, this is the mirror. Okay, so if there is a letter B, we write like this. We put a letter B outside, its image forms like this. This is called lateral inversion. So if the B was facing left, the image will form right. That is called lateral inversion. Fourth point, virtual image is always formed. Plane mirrors always form virtual image. The last one is an interesting one, helpful in numerical problems. If the object is also moving, then image also moves. Then speed of the object and speed of image are always the same in case of a plane mirror. So these are the characteristic feature of a plane mirror. So these are the two pictures. You see here, this person shows his right hand, but the image in the mirror, you see, the image in the mirror, the person's left hand is seen. The same person's virtual image you can see inside. Okay, so the real person, the person's virtual image you see in the mirror. The person whose image is seen inside the mirror, his right hand shows thumbs up, but the image's left hand is showing. This is called lateral inversion. That is a characteristic feature of a plane mirror. And here in the second picture you see, object distance and image distance are same. So in case of a plane mirror, at what distance we are standing in front of the mirror, our image also forms at the same distance inside the mirror. That's a characteristic feature of a plane mirror. Now coming to types of mirrors. So that was the plane mirror. So there are two types of mirrors. One is a plane mirror, another is a spherical mirror. What is a spherical mirror? Spherical mirror, there are two types of them. One is a concave mirror, another is a convex mirror. How do we define a spherical mirror? From now you keep on listening to the definition. That's very important, because every part of the definition that I say orally without writing is a 1-mark question that we see in the exam. So spherical mirror, what are spherical mirror? Concave mirror and convex mirror are spherical mirror. So these are spherical mirrors are part of a hollow sphere. So the picture that you see on the screen is a hollow sphere. The part of the hollow sphere, if the outside part is painted with black, I am showing you, if the outside part is painted and the inside surface is the reflecting surface, outside is painted and the inside surface is a reflecting surface, then such kind of a mirror is called a concave mirror. So what is a concave mirror? Concave mirror is a part of a hollow sphere whose outside is painted and inside is a reflecting surface. And then what is a convex mirror? Convex mirror is a part of a hollow sphere whose inside is painted and outside is the reflecting surface. So this is how we define a convex mirror and a concave mirror. So convex mirrors outside is convex mirror, inside is reflecting and inside is painted and outside is reflecting surface. Concave mirror, outside is painted and inside is reflecting surface. Now let's talk about parts of a spherical mirror. Okay, so let me begin with the first part. First part is called aperture. What is the meaning of aperture? So these are definitions. If you would like, you can note down. So aperture is the size of the mirror. You see, this is the size of the mirror. So size of the mirror is what? A diameter of the mirror, because these are spherical mirrors, so we can talk about diameter. Diameter of the spherical mirror, that is a concave or convex, is called the aperture. Then the first one is aperture. Next is pole of the mirror. What is the meaning of pole of a spherical mirror? So first we spoke about aperture. Aperture is the diameter. So here we have concave mirror and in the left side we have convex mirror. So this happens to be the convex mirror. Aperture is the diameter or size of the mirror. Then pole. Pole is the center. Pole is the center of the mirror. So center of the spherical mirror is called pole. So I am writing P, but which represents pole. P-O-L-E. I am just writing P. Center of the mirror. So keep listening to the definition. Pole is the center of the mirror. Next, center of curvature. What is the meaning of center of curvature of a mirror? Center of curvature is the center of the hollow sphere of which the mirrors are a part. I wrote a letter C there. Center of curvature is the center of the hollow sphere of which the two mirrors, concave mirror and convex mirror, are a part. The fourth one, the principal axis. The principal axis. Principal axis is an imaginary line joining the center of curvature and pole of the mirror. Principal axis is an imaginary line that joins. So this is the principal axis. imaginary line joining the center of curvature and pole of the mirror is the principal axis. Then what is a radius of curvature? Radius of curvature we denote with R. Radius of curvature is the distance between pole of the mirror and center of curvature. Radius of curvature is the distance between center of curvature of the mirror and pole of the mirror. Then there is something called principal focus. This definition comes for not principal focus, principal focus and then followed by focal length. So what is principal focus? So principal focus is a point that lies halfway the distance between center of curvature and pole. So principal focus is the midpoint of the line joining pole of the mirror and center of curvature. But there is a better definition to this also. So what is principal focus? Principal focus, I'm just doing it here. Say in case of a concave mirror. So this is a concave mirror which is painted in outside and polished inside. And the center of the mirror is called pole, and then center of hollow sphere of which this mirror is a part is called center of curvature, and then principal focus is the midpoint of the line joining center of curvature and pole. So what's a better definition? Principal focus is the point on the principal axis where a parallel beam of light rays after reflection from concave mirror converge to. So in case of a concave mirror, parallel beam of light rays after reflection, they converge to. That means they all of them pass through a point on the principal axis. That point is called principal focus. What about in case of convex mirror? In case of a convex mirror, this is the principal axis. What is principal axis? That's an imaginary line joining pole and center of curvature of the mirror. So how do we define principal focus? Principal focus is a midpoint of line joining pole and center of curvature. So how do we define it? Principal focus will be the better definition: when a parallel beam of light rays from a distant object, parallel beam of light rays are incident on this mirror. After reflection, they diverge. After reflection, they diverge from a point on principal axis. That point is called the principal focus. The principal focus. So we can define like this. So what is principal focus? Principal focus is a point on the principal axis where the parallel beam of light rays after reflection either converge to in case of concave mirror or diverge from in case of convex mirror. So that is principal focus. Then what is the next part of the spherical mirror? It is called focal length. It is called focal length. So focal length. Focal length is the distance between principal focus and pole of the mirror. Distance between principal focus and pole of the mirror is called focal length. So focal length, double the focal length will be the radius of curvature, or a focal length is a half radius of curvature. So these are the parts of spherical mirror. So okay, so that will be a quick recapitulation. I just go to a plane surface where. So what is aperture? First one, aperture. Aperture is the diameter of a spherical mirror. What is pole? Pole is the center of a spherical mirror. Then what is center of curvature? Center of curvature is the center of the hollow sphere of which the mirrors are a part, or center of that sphere from which the mirrors are cut out. What is a radius of curvature? Radius of curvature is the radius of curvature is the radius of the hollow sphere of which the mirrors are a part, or it is the distance between center of curvature and pole of the mirror. Then what is principal focus? Principal focus, a definition you should know. The principal focus. Principal focus is a point on principal axis. Point on principal axis where parallel beam of light rays after reflection converge to or diverge from. That is called the principal focus. And what is focal length? Focal length is the distance between principal focus and pole of the mirror. Focal length is always half the radius of curvature, or twice the focal length is radius of curvature. So there is a relation, like radius of curvature is a twice focal length. Just remember this. We have some numericals on this. In that case, a focal length is actually radius of curvature by 2. So either use this or that. Okay. Now, before we end up this session, let us have a quick quiz on whatever we have learned. Now, the quiz. The first one, what are the laws of reflection? There are two laws of reflection. First law is angle of incidence is equal to angle of reflection. Second law is the incident ray, reflected ray and the normal at point of incidence lie in the same plane. Second question, if the incident ray makes an angle of 37 degree with a plane mirror, then what is angle of reflection? For that, let us draw a plane mirror. So this is the plane mirror and this is the incident ray. If this is the incident ray at point of incidence, we have a normal. So this is the normal at the point of incidence and this is the reflected ray. So the arrows indicate incident ray and reflected ray. The incident ray makes a 37 degree with the plane mirror. See, this is a 37 degree. Then what is angle of incidence? Angle of incidence is a 90 minus a 37 means a 63. So angle of incidence is 63. 53, okay, sorry. Okay, angle of incidence is 53. So what is angle of reflection? Angle of incidence is always equal to angle of reflection. So angle of reflection is also 53. So angle of incidence and angle of reflection is 90 degree minus 37. So this is going to be 53 degrees. Okay. The third one, name the type of mirror. Name the type of mirror used in the following cases. Headlights of a car. Headlight of a car is for focusing light. So concave mirror has the function of focusing light. So it is concave mirror. So what are the uses of concave mirrors, by the way? Concave mirror is used to focus light. So concave mirror is used in torch lights. It is used in solar furnaces where the sunlight has to be focused at a point, and where that point is the principal focus. There the boiler is placed, water is boiled, steam is produced, that steam is compressed, and that highly compressed steam runs the blades of a turbine and power is produced. So concave mirror is used in headlights of car, it is used in torch lights, it is used in solar furnaces. Concave mirror is also used in jewelry shops or as a shaving mirror, because concave mirror, when object is very close to the concave mirror, only then the virtual image, means erect image of an object forms, and that too highly magnified. Remaining all cases, concave mirror forms an inverted image, means a real image and small. So concave mirror is used as a shaving mirror because the object appears to be big. No other mirror can show or can magnify image of an object. Plane mirrors show as it is. Convex mirror will make an object's image small. Only concave mirror can magnify any object. If object is very close to the concave mirror, its magnified virtual image is seen. So concave mirror is used for shaving mirror as well as in jewelry shops to see the image of the object big. Second one, name the type of mirror that is used as a rear view mirror in vehicles. It is the convex mirror. Why convex mirror? Convex mirror has a special feature that it is bulging outward. So it is bulging outward. As a result, its view area is more. That means it can capture a wider field of view. That means it can see more. That is one reason. Number two, convex mirror never forms an inverted image. Convex mirror always forms an erect image of an object, though small in size. That is why on rear view mirror, the side mirror of the vehicles, it is written object seen in the mirror is actually closer than it appears. Okay, because object's image appears to be small, so the observer may think that the object is at far distance. That is why it appears small, but it's not so. The image is small. Okay. The third one, solar furnace. In solar furnaces, concave mirror is used because solar rays or sun rays are focused at a point, and at that point temperature rises, and that rise in temperature is used for power production. Box type solar cooker. In box type solar cooker's lid, inside part of the lid, plane mirror is used. Plane mirror is used. So this is the quiz on whatever we have learned in this session. In the next session, we will learn about rules of image formation by spherical mirrors and image formation by spherical mirrors, that is the concave mirror and convex mirror. Thanks for watching this video.